this morning. Looks like we have, what is that? Adrix, good morning, and Exotic, good morning to you guys. So who else do we have? We got Mikhail, good morning to you as well. So, all right, ladies and gentlemen. So we're back a day after. It's related to Daisy's question and related to this definition I'm going to give you guys. And you want to do it without a calculator. And you say, why? Because you want to learn the arithmetic. If you could do arithmetic, then you could do what? Algebra. You guys know what I'm saying? If you do arithmetic, you do algebra. If you do algebra, you could do calculus. You know, that's how it works. Excuse me. So let me give you a definition of what we call a perfect square. A perfect square, ladies and gentlemen. And I'm going to write it down symbolically here for you guys. What do you guys see there? There's what? There's a triangle here, and it's raised to the what? To the second power. Do you guys know what we call that, by the way? It's a perfect square. Okay, so you need to know that, and that's where we start. And so you might say, okay, by the way, this is here also known as a base, and this 2 is known as your power or exponent. Is that right? So it's really called, it's an exponential. It's a special exponential raised to the second power. And what that means by definition is you take that same base and you multiply it. That's repeat. We call that repeat multiplication. Okay, you guys see what I'm saying? So you have this base here that's multiplied. This tells you how many times to do it, and that's what you get here. Okay? So let me put this here for you guys. So here's what I'm going to say to you. Here's going to be the bases here. This is a base. And then I'm going to say, what do you do with this base? We're going to raise it to the second power here. Okay? So we go, okay, here's my base. So I'm going to start with a base being of the number 1, for example, right? And so if I take the number 1 and I raise it to the second power here, right? Here's that base. Raise it to the second power. What do we call this? Together, a perfect what? Perfect square. So we get 1 times 1. Does anybody know what is, this is without a what? Calculator. Okay, you don't be reaching for a calculator because that's not good. Because what that means is you're going to have trouble doing some algebra, right? So what's 1 times 1? Does anybody know? Good, thank you. And what you're seeing here, I'm going to color it red. This is called a perfect what? Square. So the number 1 is a perfect square. What happens if we take the number 2 and we raise it to the second power? You get 2 times 2. What do we get here? All without a what? Without a calculator. So ladies and gentlemen, you want to know those things. Okay, you guys okay with that? Does that seem too hard? No, I don't think so, because it's based on what? What's that word? Arithmetic. 3 to the second power. What's this? What's 3 times 3? 9. And what do you call the number 9? A perfect what? Square. Good. Take the number 4. Raise that to the second power. What's 4 times 4? And what do you call 16? It's a perfect square. Good. Now, 5 to the second power is 5 times 5. What's that? What do you call 25? Perfect square. What do you guys think? Is that okay? Is that easy? Well, what if you said, you know, Mr. Judge, I got 6 times 6. I know that's what? 36. Take 7, raise 7 to the second power. 7 times 9, what's that going to be? 49. Take 8. 8 squared is 8 times 8 is 64. 9. 9 squared. 9 times 9 is 81. And what's 10 times 10? Is that 100? Okay, so what do you guys know about this? 36, 49, 64, 81, and 100. We call these numbers what? Perfect squares. Okay, you guys okay with that? Is that okay? Is that easy? Okay, now, here's the thing about it. I'm going to take a letter like X. I'm going to raise X to the second power. Okay? You know what that means about the term called X to the second power? What does that mean? It is X times X. But what do we call it? It's called it's in red, like all these other numbers in red. Perfect square. There we go. We're looking for that word. Okay, you guys, isn't that kind of easier? If you got a letter like Y and you square Y, what do you think that's called? A perfect square. Okay. What if we get a letter like Z? We square Z. What do you think this is called? Perfect square. Outstanding. You guys see how easy that is? So we have this extensive list of perfect squares. What if I take X? I'm going to take an X squared. And I'm going to do this now. This is my base, right? All of these were bases. Notice that. Okay? And we put it here. Here's the base. Here's the base. These numbers were bases. Is that right? Okay? What do you think happens if I take the base X squared and I square it? Now, this is where beginning algebra comes in. Right? And it's related to your question, Daisy. It's very much related to your question. You see, if you said, hey, why don't they offer Math 125 or something? Because they feel everybody knows all this stuff already, and we're wasting everybody's time, money, and energy because you know it. So they want to put you directly in a transfer level math class, even if you fail. But they'll say, take it 3 or 4 times and good luck, and you'll be okay. You guys know what I'm saying? I don't know how you feel about that one. It's like saying, hey, we think you know how to swim. We're going to drop you in the ocean, and let's hope you actually get to the other side. But guess what? If you don't get there, we'll give you more tries. Well, you might say, but what happens if you fail in swimming? The worst happens. But what do you think might happen to somebody if they fail with placed in a transfer level course without the skill sets? You might say, well, they don't exactly drown, but I'll tell you, maybe they do. You guys know what I mean? Maybe there's wrong one. We don't want to say that's a happy thing. I want to go here. Let's think about that, right? We don't want you to drown. So here's what I'm getting at. You guys remember this. This is called something, by the way. This is called what? When you take a base, an exponential, and you raise it to another power. Does anybody know what this becomes? Since remember, they claim everybody knows this. We don't even have to do it. So what do you think that becomes? This is the base to the what? N times n power. Do you guys remember that? That's from beginning algebra. You guys see what I'm saying here? This is what it is. So you're going to take that base. Do you guys remember from beginning algebra? What do you do with the powers? You multiply them. Good. That's what this property is, right? So you're going to take 2, multiply it with 2. What does it give you? Is that x to the 4th power? You know what that means about x to the 4th power? It's a perfect what? Square. All righty. Okay. What if we take x to the 3rd power, that base, x to the 3rd, and we square that base, right? By that property, what happens here? Do you guys know what that gives you? X to the 3 times 2, which is what? X to the 6. Maybe I'm wrong. Maybe you guys know all this stuff already. Okay, good. All right, pretty good. Okay, now let's take the base x to the 4th, x to the 5th, x to the 6th. I want you guys to generate the perfect squares. All these things are called perfect what? Squares. This is 4 times 2. This is 5 times 2. And this will be 6 times 2. What do you guys get? What's 4 times 2? What's 5 times 2? 6 times 2. And what do you guys notice here? These are all called, yes, let's put this, I'm going to put the phrase down here again. Everything in red is known as a perfect what? Square. There you go. Okay. You guys good with that one? Now, I'm going to give you guys this big question here. So I'm going to put that here in purple from beginning algebra. Here's the big question they want to ask, right? Why do you think we care? So I'm going to write this down. Why do we care about this thing called perfect squares? Why do we care about perfect squares? And I'm going to give you guys the reason. Are you guys ready for the reason? It's because of this symbol here. Okay? Does anybody happen to know what kind of symbol that is? Yes, this is called, by the way, the square root what? Symbol, ladies and gentlemen. This is our square root symbol. So when you have a square root symbol, what do you think that means? If they say to evaluate, and they will, the only thing you can evaluate is a square root of a what now? What's under here? Yes, you can. This is saying what? You must have under here a perfect what? Square. Outstanding. You have to have a perfect square to do what? To evaluate the radical, or this in particular, the square root. This is also known as a radical sign. All right, so you have a radical sign, you got a square root. What do you guys think? Is that easy or is that hard? You're gaining some knowledge. This is why you're here. Is that right? This is why we get up in the morning. So let me share with you guys how to take the square root of a perfect square. Do you guys know what the answer is? What do you think that is here? Okay, so I'm going to say this here. You're going to evaluate this. Under here in red, what is this? We call that a what? Perfect square. The square root of perfect square, what do you guys think this is? What is this known as? Isn't that my what? Good. I like you guys. That's the base. Yes. Isn't that the base? You guys with me on that one? This is the definition. This is what you always use to evaluate a what? A square root. Okay, you guys, okay, so let's give you guys an example here so you understand my point. They're going to say, take the square root of 4. Okay, so let's ask you. Is the number 4 a perfect square? Yes. You know what you could do then? You can evaluate the square root of 4. What do you need to know? I'm going to say you need to know the base. So let's go up here. Remember this list? You see this list, ladies and gentlemen? What's this a list of? It's a list of perfect squares, isn't it? You guys okay with that? You guys just told me 4 is a perfect square. What is the base, though? What was raised to the second power? Here's the base right in here. Do you guys see what I'm saying? So you got the perfect squares and you got the bases. The bases are the answers. So what's this answer? Outstanding. This is the number what? 2. See that there, ladies and gentlemen? The answer is the base. Okay, so this is like the fundamentals. You see, this is what I've been saying to people my whole career, my whole life. If you want to learn algebra, you got to know arithmetic because the definitions are based on arithmetic. The work is based on arithmetic. So if you see this definition, you could take the square root of 4 and know it's 2 because you actually squared 2 to get 4. You guys know what I mean? And this brings you up to another point because this is kind of what people need to do, okay? What you guys want to do, I think this is imperative. You're going to be using this information for the rest of the course. You're going to be using this. So what's the best way if you say, okay, Mr. Judge, I'm going to be using this. How do you go about it then? What do you think you should do if we're going to use this list? Anybody know? What's the best thing? You might say, Mr. Judge, I need to memorize this list. And I'll say, yes, sort of. How do you begin to memorize the list? Anybody know? Because I remember when I had to do this when I was a young, whatever I was, younger, a young chap. Is that right? A young guy. Who knows? You know what I had to do? I had to write down this list like every day. 1 squared is 1. 1 times 1. 2 squared is 4. 3 squared is 9. I had to write it down. And I wrote it down until I knew, I think I know this list. I know how they're getting it. That's how you do it. Think about, how did you learn how to spell your name? Were you born with it? Do you guys know what I mean? You're not born with knowing how to spell your name. What did you have to do? Write it down over and over. So I tell people, practice that list because you're going to use it for the whole semester. You know what some people are going to do? They're not going to practice that list. And then at the final exam comes, you go, Mr. Judge, can I bring that list on a test? I said, no. Because where do you want to put the list? In your what? In your brain. That's where I'm saying you put it. That's why you practice it, write it down. I even say, put this on the refrigerator, this list. Why do I say that? Well, how many times you go to the refrigerator every day? Do you guys know what I mean? If you're like me, probably like 25 times. You guys know what I mean? Getting some ice cream, getting some punch, getting a snack. You guys know? Is that where you go? You guys know that? You know what I'm saying? You say, no, Mr. Judge, I don't do that. Okay, where do you spend your time? Put it on your phone. Put it as a screenshot on your phone then. Put it in the mirror. You said, I spend all my time in the mirror. Okay, put it in the mirror. Put it where you're going to look. Not on your car mirror. Put it on your mirror at home. You guys know what I'm saying? So that's the list you guys want to know because it's important. If it was so simple to say to you, and this is the problem with what's going on right now in a lot of ways, a very big way. What's the square root of 9? How did you know that? Were you born knowing it? No, because you generated the what? The list. You guys see what I'm saying? So you want to be able to do that. It's important because if you can't do that, you're going to get slowed down in the work in the future. It's going to slow you down. You're not even going to be able to process and do all the other work because you're so busy trying to. Sometimes people say, I'm going to look back at a table all day long and get my answers because I don't want to think about what I'm doing. That's a problem. You might say, well, I'm just going to use a calculator because, that's why they're here. And it's like, well, that's a problem. It's going to slow you down. You're not going to be able to process the rest of it. Trust me on that. I'm an expert in what? Learning math. I'm an expert. Okay, you guys okay with this? It's important. So that's what I have to say. And it isn't so hard. Maybe at first you say, boy, that's the first time I've seen the list and I hate it. Well, after you practice generating your perfect squares, you're going to know what the square root of 25 is. See how you know it already? How did you know it? It is 5 times 5. You guys see what I'm saying? So you're knowing the definition here because you can only take the square root of a perfect square. So right in here, the square root of 25 is going to give you 5. The square root of maybe 100. Oh, you see, you guys know this? Good. Okay, square root of 100. The base was what? 5, right? Or 10. Here the base is 5. Here the base is 3. Here the base is 2. Now you know this because you already generated this stuff. You guys see what I'm saying? That's how you do it, ladies and gentlemen. There's no shortcuts. Trust me. I know we live in an age and a time where all we want is a shortcut. And I'll tell you, there are no shortcuts. Don't believe people that tell you there's shortcuts. You will pay for it in one way, some way, somehow. And that's what that's kind of my message to you guys here. Square root of 16 is what? Good. 4. Alrighty. Okay, now I'm gonna trip you guys up. I think you guys are ready for the hard one. Do you guys know what the square root of 1 will be? Is that the hard one? You square root of 1 is 1 a perfect square? Okay, good. What was the base? 1, because it's 1 times 1. You guys see what I'm saying? That's an important thing. Now I'll give you the hard one. Square root of x to the second power. What's the square root of x to the second power? That's just a what? It's an x. There's your base. Ladies and gentlemen, you say, how is the square root of x squared just x? Oh, do we have an x squared? Oh, yes, we do. It's right here. You see this? Here's the answer. I'm going to erase it. X squared is a perfect square, so the square root of x squared is x. It's always the base. So let's see if you're awake. I'm going to have you guys try these. Give me the square root of y squared. The square root of x to the 4th. The square root of z to the 6th. Square root of x to the 8th. Okay, I'm going to give you guys some time to think because it's always good to do what? To think. You guys think it's good to think? How many minutes should we give you to think? 5? I know we like that music, but let's minimize it. All right. Here we go. So what would you guys think the square root of y squared would be? Is y squared even a perfect square? How do you guys know? You might say, is it on the list? Well, it is actually on the list. Y squared's a perfect square. You say, it's right here, isn't it? Then what is the answer? What was the base? The base was y. So ladies and gentlemen, what would you guys say? That's simply y. Okay, you guys okay with that? There you go. This is going to be a y. What's the square root of x to the fourth power? Is that even on our list? Double check. Here it is. You guys see what I'm saying? X to the fourth. What's the square root? Right? Square root of x to the fourth then would be x squared. You see how we squared x squared? So this is going to be x to the what? Second power. Okay, you guys okay with this one? What do you think the square root is? Z to the sixth of a perfect square. Right? And x to the eighth, are they perfect squares? What do you think z to the sixth would be if we took the square root of it? Is it z cubed? You guys want to vote on that? Is it z cubed? How do we know? If we took z cubed and we squared it, isn't that 3 times 2, which is what? And ladies and gentlemen, sure enough, you are correct. So you might say to me, Mr. Judge, how did you know that? Because we use the definition again, right? I took that term, z to the third, I raised it to the second power, and sure enough, we know it's a perfect what? Square. So yes. What about x to the eighth? You're going to say, is that x to the fourth? What happens if I square that one? Right? Is that 4 times 2, which is? So that's x to the eighth, ladies and gentlemen. So there it is. And sure enough, what's the base? It's x to the fourth power. And there you go. So you might even say that was on the list. So do you guys see why it's important? Well, it wasn't, but we just put it. Do you guys see why it's important to generate the list yourself? So that you start to get to know these terms and know these numbers very, very well. Right? It's about knowing the numbers and knowing the terms. That's a pretty big deal. And let me give you guys a fact in case you didn't notice here, right? Let me give you guys a fact. Do you know this like x squared, x to the fourth? You see this? Did you notice this pattern, by the way? Right? You see this? You got x squared, x to the fourth, x to the sixth, x to the eighth, x to the 10th, and x to the 12th. Did you guys notice that pattern by any chance? Okay. I'm going to write down the pattern here. Right? This will be x to the 6th, x to the 8th. What do you guys notice about this pattern? This is x to the what? Even power. Is that true? So all of these powers you guys see are even. 2, 4, 6, 8, 10. This is why even you want to know the definition of an even number, what they are, right? So here's a powerful fact I'm going to give you. I'm going to say you can take the square root of x to an even power. You know what it will always be? What do you think it'll be? See if we see a pattern. What's the square root of x squared? That's just x. What's the square root of x to the fourth here, right? So I'm saying here's x. That's really x to the first power, by the way. What's the square root of x to the fourth? What about x to the eighth? X to the fourth. What if I said the square root of x to the 10th? What do you think that would be? How did you know it's x to the 5th? x to the 5 raised to the second power, and that's 5 times 2, and sure enough, yes, it's x to the 10th. You guys okay? Do you guys know what I'm saying here? This is x to the even divided by 2. If you notice that relationship, do you guys think that this is a very helpful relationship? What do you guys think? Is this a true statement? You can take the square root of x to the 10th and it's x to the 5th. What's 10 divided by, here's what I'm saying here, right? What's this 10 divided by 2? That's x to the what? 5th power. Okay, you guys see what I'm saying? Is that a useful fact? Well, what if they ask you this? What's x to the 84th power? X to the what? 84 divided by 2, which is x to the 42nd power. You guys okay with that? You guys see what I'm saying? So I think to say to you, since I know this is x to an even power, that power divided by 2 is, this is how I can actually also find the square root of those kind of terms. What do you guys think? Is that easy? Well, let's check. Does it matter if the base is x? Can I change the base on you? Can I use y, z, a, b, c? So let me ask you guys, evaluate. Let's see if you're awake. Question 1. Square root x to the 14th power. Question 2. X to the 20th power. X to the 32nd power. Y to the 10th power. Z to the 16th power. W to the 24th power. And then number 7, I'm going to do number 7 right here. Square root of 4x to the 2nd power. So I'm going to give you guys some time here to try this out. Let's see what you guys get for some of these. I'll give you guys a few minutes. Let's see how that goes. All right, ladies and gentlemen, let's take a look here. All right, you guys, it's 11:11. Should we make a wish? I wish we keep Math 125. You imagine if they said you get to go straight to college algebra instead because you're ready, because we know you know all this. What's going to happen? You're going to drown. Is that good to put you in a position to drown? What do you guys think? I don't think it's good to put anybody in a position to drown. That's horrible to me. That's just completely horrible. Anyway. $14 divided by what number? 2. You guys okay with that? 20 divided by 2. 32 divided by 2. Is that 10 divided by 2? What do you guys think? 16 divided by 2. What is this? Is that 24? So do you guys, let's really focus on this. What do you guys know here about 14, 20, and 32? They're even, is that right? So if you take 14, 20, and 32 and you divide by 2, you get the answer. You just have to know how to do some what? Thank you, some arithmetic. You guys see what I mean? You could do algebra if you know what? Arithmetic. So what is 14 divided by 2? Outstanding. The answer is x to the 7th. There you guys go. You guys see what I mean? Who says you can't do this because you can? And then what's 20 divided by 2? Outstanding. Good. You guys okay with that one? You guys see what I'm saying? And then what's 32 divided by 2? And there you go. This is the answer. 10. Looks like we need more space. What do you guys think? What's 10 divided by 2? And then what is 16 divided by 2? Is that 8? And then what's 24 divided by 2? 12. Good job. So make sure you keep the base and you change the power because you know how to divide by the number what? 2. And there it is. And that's it. What do you guys think? Is that easy? Is it doable? Or is it impossible? What do you guys want to put on your phone as a screenshot? Put your perfect square list. You guys, people think I'm kidding. I'm not kidding with that. I used to write it every day. And then I'm like, oh, I think I know this list. And then I had a copy of the list and I kept looking at it. That's how I learned it, ladies and gentlemen. I'm telling you something. I'm telling you to do something that I had to do. You guys see what I'm saying? Stop and think about what you do all day long that you shouldn't be doing. Should we go around the room and start asking questions? No. You go, Mr. Judge, I spend too much time on Facebook. Do you imagine if you put the time on Facebook, the same time on Facebook as you do on your math homework? How well do you think you would do? You do very good, ladies and gentlemen. I'm telling you, you would. How do I know? Because I used to do the same. It wasn't Facebook, but there was other things. That's how I know. I just changed what I put my time on. All the fun things, I said, forget it. No more fun for me. I got to do my work. Do you guys see what I mean? Maybe you spend too much time on Instagram. Snapchat. What's the other one? TikTok. Meta. Am I missing any? Twitter. Which one? What's another one? I don't even know. I can't hear. Tomlick? Oh, Tumblr. Okay. Maybe you spend too much time on Tumblr. On Netflix. On Hulu. Yeah, don't even go on Amazon. Forget about that one. Stay away from Amazon, ladies and gentlemen. Amazon's dangerous. And besides, how do you know some of the things you buy on Amazon are legit anyway? There's a lot of illegit things on Amazon. You guys know what I'm saying? No, maybe you guys don't know. Counterfeit. There's a lot of counterfeit things. Counterfeit goods. So what I want to express to you guys here, this is something interesting here. This is new. You got a number like 4, and you got an x squared here. Okay, you guys see what I'm saying? And what's happening between those two terms? You got multiplication, because if there's nothing there, that means to multiply. So what I'm going to give you guys here is a rule when you're in that situation. It's an easy rule. We call this the product rule. You know what the product rule says? To multiply. So if I take triangle squared times square squared, this is when we say product what? Rule. What do you guys know about the number 4 here? It's a perfect square. Good. What do you guys know about the x squared? Yeah. So what I'm going to say to you guys, here's the product rule. You can take the square roots of each perfect square separately, and you multiply. Do it separately. You know what you end up with? Triangle times the what? Square. Okay? So in other words, what you are doing, you're going to do them separately. So you said, okay, number 7 comes along, and I got to do the product rule. Square root of 4 times square root of x squared. What do you end up with? 2. What's the square root of x squared? Do you guys know what's going on here? You're done. Just do them what? Separately. I'm going to write this down. Just do them separately. And there you go. Easy. What's the word? Easy breezy? You guys ever heard that? Easy breezy? Yes. Well, be careful. I don't want to say, I'm not going to use the word cancel. I'm going to use the phrase, we take the square root of 4, and we take the square root of x squared. We do them, what's this phrase? Separately, yeah. Well, we didn't simplify it, we took the square root of 4. See, it's important to use that language too, because then you can tell yourself what you're doing. We're not simplifying, we're taking the square root of 4. Do you guys see what I'm saying? It's good to know the language and the process. There's a relationship between language and mathematics, really language and everything. So I always focus, ironically, on the language. You know, here's another one just to see if you're awake. The square root of 1 over 100. Okay, you guys see this one here? Do you guys know what's happening? What's this under the radical? You guys know that's a fraction, is that right? This is also known as a quotient, by the way. What's a quotient? Do you guys know what a quotient is? A quotient is to divide. So quotient means to divide. You have the divide rule. You go, oh, got quotient rule, divide rule. Square root, perfect square over another perfect square. Okay, you guys okay with this one? Your first perfect square, and now your what? Second perfect square. What do you think you do? Like the product rule. Do them separately. Outstanding. Do them separately and divide. So here you guys go. Quotient rule. So you're going to end up with, notice this, is 1 a perfect square? So isn't it important to know that? Is 100 a perfect square? Is that important to know it? Okay. And what do you think? What does this line mean? Divide. You guys see what I'm saying? This is the quotient rule. So you take the square root of 1 separate from the square root of 100. 1. Excuse me, 100. What's the square root of 1? What's the square root of 100? So, ladies and gentlemen, what's your answer? 1/10. So notice, when you get home this afternoon, what are you guys going to do? Make a chart, put it on my wallpaper. Make your own, do your own list every day until you know these perfect squares? Because you go, oh my God, are they going to ask me these kind of questions? Yes, they will. They can say, the square root of 4/9. You know what that is? Do them again, the word separately. Yes, you do them separately. Outstanding, because 4 is a perfect square. 9's a perfect square. So you got the square root of 4 divided by the square root of 9. You guys know what that gives you? 2/3. Ladies and gentlemen, there you go. Easy what? Peasy. Is that the phrase, easy peasy? Is that right? Easy peasy. I don't even know the meaning of the word peasy. What's peasy mean? I don't think peasy means anything. Peas? Is that what they're saying? Easy peasy? Do you guys even like peas? I do. I like peas. You guys don't like peas? Peas are good, aren't they? They're delicious. Do you eat them in your rice? There you go. Okay, my grandmother used to make her rice with peas. I don't know. And then I like a lot of people make their rice differently. You know what was in my grandmother's household? She'd make her rice with peas. Peas and onions. Anybody else have their rice with peas and onions? Or is it just me? Does anyone else in the room, they put peas and an onion in the rice? Peas, onion, garlic, tomato sauce in the rice. That was your rice. That was the Spanish rice, right? Peas, onion, garlic. Anybody else in this room, or is it just two of us? Sometimes people, I know, I've had that where sometimes people put corn. They put what? Ejote, really? Yeah, what I've really noticed is there's a diversity of Spanish rice. I heard about that. Putting banana? Is the bananas cooked? Oh, really? And you put some banana? You stir in some banana? You slice some bananas and put it in it to sweeten it up. Now I'm gonna try that out. I'm gonna try that one. I'm gonna put it in the sopita, put it in the rice, bananas. That's a new one. That's new. I'm gonna ask my mother-in-law. Say, how come you don't put any banana in this? I'm trying to think. I don't think my mother-in-law puts even peas in her rice. You know what I mean? She doesn't even put the peas in them. I think it's just onion and garlic. Quotient what? Quotient rule. You imagine every time you got an answer right, you get a spoonful of rice. Yeah, well, I know. I mean, yeah, rice is kind of tricky, you know. Even tortillas are tricky. How many tortillas you eat in a day? Yeah, you gotta be careful with the tortillas. You guys know what I mean? You gotta be very careful. And then if you have like Pepsi Cola or Coca-Cola, you imagine you eat rice, Coca-Cola, tortillas. Got to be careful. I know, but I'm talking as a diabetic, ladies and gentlemen. I have diabetes, and that's like the worst thing you can eat. Rice, tortillas, and Coca-Cola. Forget it. the best thing, though. It's horrible. You imagine? No rice for you. No tortillas. I used to eat just 4 with dinner. You imagine? I didn't even know how to use a fork because I just used tortillas. I had to start using a fork. Jesus. Horrible. Did you guys get X squared over 4? Yeah. I had a student of mine, you know what he told me once? You guys are going to laugh. Maybe you're not. He told me, Mr. Judge, have you ever had a spaghetti taco? I said, what are you talking about? I don't think I've had a spaghetti taco. No. What is a spaghetti taco? You make spaghetti and you put it in a tortilla. Exactly. Exactly. That's what I'm saying. Where it probably isn't too bad because if you're like me eating tortillas, no fork, that's where spaghetti tacos come in. You guys know what I mean? I don't know. Maybe you guys just don't know. You guys never had a spaghetti. I was like, never thought. I go, okay. I've had weenie spaghetti. No, everybody know what weenie spaghetti is? You ever had weenie spaghetti? You don't want to know what it is? No? Well, I remember my grandmother again. There comes my grandmother. Poor grandma. You know, she would make spaghetti, but instead of having in your spaghetti like ground beef or like a meatball or something, you know what she'd do? She'd get a weenie. She'd chop it up, she'd cook it, and that goes in your spaghetti. It's called weenie spaghetti. Anybody have that before? Yeah, exactly. Have weenie spaghetti. I thought it was weird when I had real spaghetti because it didn't taste like weenie spaghetti. That's the truth. Weenie spaghetti. I just had to think about that one. I go, yeah, I remember doing that. I might even try that later. Just kind of remember what that was like, weenie spaghetti. I transitioned to ground beef. Right? What rule is this? Is it quotient? Let's think. What is that one? What is this called when you see it? Yes, it's product rule. What am I really saying you guys do? Do them separately, one at a time. That's what I'm saying. Do them what? Separately. And what's the square root of 25? And then, look what I'm going to do. You guys are going to like this. I'm going to give you every detail. 4 divided by 2. And then what? 6 divided by 2. You guys see what I'm saying? Is that consistent with what we've been doing? So you get 5 times a squared times b to the what? 3rd. What do you guys think? Isn't that consistent? No, you guys don't like that one? Let's give you one more for the road. Square root 36 over x to the 6, y to the 12th. Let's see if you're really awake on this one. You got a numerator, you got a denominator. Quotient what? Quotient will take the square root of 36 over square root of what? X to the 6 times y to the 12th. Okay, you guys with me on that one? And then you can see every step. Here's the numerator, here's the denominator. And what do you think the denominator becomes, right? Yes, good. This is the product rule down here. Do them what? Separately. So they're all separate, all these perfect squares. And then I could tell you, I know the square root of 36 is 6. X to the 6 divided by 2 12 divided by 2. This is 6 over x to the, what's 6 over 2? 3. And what's 12 divided by 2? And ladies and gentlemen, there it is. What do you guys think? Is that easy or is that hard? When do you guys think the best time to do your homework is going to be? Now.